All right, this is the example summary activity for verification after the top exoplanets have been selected by the class. So we're going to demo 55 Cancri b, and the importance of this activity is to verify what scientists have done, because this is part of the scientific process where scientists do not just publish their work and that's the end of it. Scientists publish their work and then other scientists check it and double check it and triple check it, repeat their work, et cetera, et cetera. So we are practicing the scientific method when we do this activity. So what you're going to do is, this is a smaller version of your original research packet. There's a lot less that you're going to be looking for here for each of these candidates. You will have between, depending on the class, 3 and 5 candidates. The current class has 3 candidates that they will be doing. This is one of them. Okay, so I'm going to go ahead and get started with this. We're doing 55 Cancri b. So I'm just simply going to go into Google. All right, so I've gone to Wikipedia. Wikipedia is fine to use for this. So I noticed right away that this says 55 Cancri capital A B. So that tells me right away that this is an interesting system because it has 2 stars. It has an A star and at least a B star. So I'm going to go over here and I'm going to, that's not the one I want, so I'm going to close that. This is the one I want. And I'm going to make a correction there and add an A to represent the star. Okay. All right, and then I'm going to come back here. I need the I need some information. So let's just see what I've got on here. I have got over here, I've got semi-major axis. Semi-major axis is the distance that the planet is from its star. So I'm going to snag that. I'm just going to copy and paste, and I'm looking for distance. Right there it is. And I want to be able to see it, so I'm going to make it bigger. So now what you should be doing while I'm doing this is you can duplicate it. I will post this in Google Classroom. And I need the link where I got it, so that I've done that. I'll go back here, there's eccentricity. So I'm just going to snag that as well. Make it bigger for you to see. Orbital period, 14.65 days. I don't need all those little, and that tells me it's days. Make sure you get the units on that. That's important. And that's days with units, so that's important. Make sure you get that. All right, mass. We want the mass of the planet. This says mass. All right, it's 0.824, but notice the units. They're Jupiter units. All right, but you need to give the information in Earth units. And there's 4 stars by this listing, so that means there's a note down here. Minimum mass is the mass of the planet compared to either Earth or Jupiter. Use Earth units. If you find a mass in Jupiter units, convert it by multiplying by 317. So that's times 317 equals. So 317 times 0.824 is 261. that is the correct size. Whoops, I didn't want to do that, of the planet. Okay. Now, the planet classification, there's 5 stars there. So that means there's another note below here. 5 stars. Use the chart on the following page in your minimum mass in Earth units to determine the planet classification. So 261 falls in this category. That's a Jovian. That's how you do that. Now, I found all of this information, all of these at the same website. So I'm going to paste those links in there. Okay. All right. Now, I still need information on the star. All right. So I'm going to go back here and see if there's stuff about the star. All right. So this particular page is only on the planet. So there's a link. No, that's not. That's this. Well, it might get us some information. It says B. So let's go there and see what's there. 55 Cancri. Okay. And then here is A, and there's information on B. So that just says the location. That's not helping us. There's the spectral type. It's a K-type star, KV. That's just a source. That doesn't help me. Distance, mass. There's my mass. 0.96, and I want to verify the units. That's in sun units, solar mass, sun units. So that's what I need. Okay. And I still need the type of star. Type of star, type of star. I'm reading. Binary system, K-type star. The small one's a red dwarf. A K-type star is an orange dwarf. Okay. All right. And I need that source. Okay. So that gets me all of that. All right. So I still have to do this, habitable zone range. And this tells me to go to the summary activity graph, Google Slide Manipulative. So that is also in Google Classroom. So this is the one I'm going to use for the example, but the one I assigned you is in yesterday's activity. All right, so I'm going to open that. Now you're going to have one of these graphs for each of the planets you're doing. So you're going to do one graph for each planet. So 55 Cancri B. So now I got to go back here and get my star mass. Okay, and my planet distance. Okay. All right. Now, what happened to my lines on this? My lines are gone. All right. Let me grab some lines here. Yeah, that's not what that. I lost them here on my manipulative. Oh, I must have screwed that all up. I'm gonna have to fix that for you guys. I think I know what I'm doing half the time, and I don't. I'm always messing stuff up. All right. So let me insert some lines here, since I accidentally removed them. All right. So there was, there was a, there were some blue ones. All right. So there were two red ones like this. Hopefully it doesn't mess up your stuff. All right. So there were two red ones and then there was a blue one. And then there was a horizontal one too. So let me make that as well. All right, two red ones. Then there was a horizontal one. All right. All right. So there were three vertical ones off to the right, and then there was a horizontal one. So the first thing you do with the horizontal one is put it where the star mass is, 0.96. So this is 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9. 9.6 is almost at the 1. And you're going to put it there as best you can. All right, now the blue one you use for the planet distance, and the red ones you identify the habitable zone. So you're just identifying the habitable zone exactly like you did when you did this for your own system. You put one red line at the hot edge of the habitable zone. You put one red line at the cold edge of the habitable zone. So you've got one here and one here. So the habitable zone's right in here, where this little bit of the line for that represents the mass of the star, right there. That's the habitable zone. So you read that off the bottom here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.75. And then the other side is this line, which is right there. So that's about 1.7. And that's astronomical units. And now our planet goes at 0.11. 0.1, 0.11 is just to that side. So that planet is not in the habitable zone. If it was in the habitable zone, it'd be right here. Right here. But it is not. Okay, so we need our habitable zone range. And that goes right there. And then we need planet location relative to the habitable zone. It is not in the habitable zone and it's too hot. It's between the habitable zone and the star. The star's over here. Outside of habitable zone, too hot. Okay. All right, so then the next thing we have to do is put our planet system into these spots right here. So I'm just going to grab the name of the system. And let's see what we've got. It's an orange dwarf. So that goes there. And I want it to stand out. So I'm going to do something to it there. All right. What else? Habitable zone. And eccentricity. All right. Distance, eccentricity. 0.014. 0.014 puts it here. Okay. All right, and it's not in the habitable zone, too hot. And then there's one more and it's tidally locked. So for that, I got to go back to this. So there's the tidal lock line right there. So if it's tidally locked, it's between the line and the star, and it is. So it is tidally locked. All right, that's our system. So now you need to do that for the other two planets. I've done 1/3 of the assignment for you. So now you just go back and do the other two.